Hello, my name is Rob, and today I will show you how to use the FLatCam software to generate the G-code for the CNC machine, step-up CNC machine, or any other CNC machine. First of all, let's start by calling the program. It's coming anytime now. This is the interface of the FLatCam. Just move it down a bit. Now we need to select for the project option. We need to select inches. We do this because when we load the Gerber file and the trail file, when you select this in millimeters, the unit in millimeters, and you load the file, you see there is an offset between the Gerber file and the drill file. So we load up all the file in inches, then we change to millimeters, and this one seems to do the tricks. We load up the file that are interested in. For this test we're gonna do a single size PCB, so we need the top Gerber file, and also this is the trace for the top Gerber file. We need also the border cutouts, and also we need the drill file. When opening it, just select the Open Excel from the menu instead of Open Gerber file. So you got your drill here. It's important to load all the files that you need at once, because you're gonna have kind of offset if you do all modification, then load up a new file and do a new modification. So we do this change to millimeters because I'm confident or comfortable working in millimeters. So just doing the change. Now our unit is millimeters, and as you can see, this is a 0, 0, and this is what is going to start the machine where it's going to start doing the job. And what we need to do now, we need to offset the position, 0 position, to here. So what we need to do, you can click on this one, then press Ctrl C, like copy. Then, for example, use Paint. Oh, sorry, not Paint, Notepad, and save this coordinates in here. I'll show you what we need. We need to offset the drawing. Put minus here and minus here. Then copy this by pressing Ctrl C. Then you need to offset all the file at the same time, so we're doing them one by one. So we select the first Gerber file, we go to select, and we go down to the bottom, and where they say offset, here say offset, so we need to offset the first file. So this is going to just move to the new position. We also need to do that for the border cutouts. So we go down to the bottom, and we paste the value of the new coordinate or the offset coordinate. And also we need to do this for the trail file. So we go down to the bottom and we paste the coordinate. Okay, so now they moved all to the new offset coordinate. We just press 1, and it's supposed to come back in a minute. What's going on? Okay, that's your new file. So your 0 is about here. So that's easy. So the doesn't have to move from here to here to start working. So you start from here and straight away into drilling or engraving or do anything else. Now, after doing this, now we're gonna start working on the file one by one. First of all, we're gonna start working on the top electric layer. So it's up to you if you feel comfortable or no, but you can deselect that further you don't want to see. This is not disturbing me, so I'll leave it. The trail is a bit disturbing me, so I'll take it off. So now I'm going to select my top layer, and now I will create my isolation file first of all, and I'm using a tool diameter of 0.1 millimeter, and then I press this generate geometry. Will generate a new file, and this new file is this one here, and that file is the isolation file. The way I can see it, I can disable this, I can select, and you can see. So by zooming to the file, I can see this is the path that the tool is going to do around the tracks, and you will isolate the track from the rest of the copper. Don't forget, all this is a copper, so you will isolate the track from the copper. That's what I want. And when you do this, make sure that the isolation is all around, and sometimes if there's no space, you will not do the isolation completely, so check that before you continue. I'm happy with it. I'm happy with my isolation. I'm happy with it. Oh, where did it go? Okay. I'm happy with my isolation. So I'll move to the next stage. When you move to the next stage, so I'll be working on a new file. And this new file will tell the machine what's the engraving that's going to be. So I put, because I got like a copper, very thin, I think 35 microns, so I'm going to go for 0.15 millimeters. And when the tool is not engraving, it goes up from the PCB surface by, let's say, 8 millimeters. So I call it a safe travel when you travel. And then I say for the speed of the movement of the tools on the plane XY, it's going to be like 200 millimeter per minute, and this is not to change. This is the same tool diameter, and I'm going to say I don't think this is going to have any effect, but I know the speed of my spindles, so I'll put it there. Now I will generate the isolation file, CNC isolation file. I can see it here. This is the new file, so I can always select this one. So you can see this is, it will show you, we zoom into it, it will show you what the machine gonna go by, what it's gonna do. This number here is just like a number of jobs. So you start by this one, then this one by number. Okay, so we did that, generate that isolation file, and this is, then we got the last step to do now. What we need to generate the actual G code. So when generating actual G code, you can just leave this empty and press on export G code. But if you want to add some G code at the beginning and at the end, so what you do, for example, in my case, I put G00, sorry, 00 Z10. So I ask it to lift the tools up by 10 millimeters, then go to position X0, leave space just to make it understandable, 0 and Y0. So copy and paste that to the end of the G code, up to the end of the G code. But in this case, I will set it to, when you finish, clear up the way for me, so I can clean the PCB, so I get it to go on the y-axis by 250 millimeters. And now I say export the G code. So I create a folder already for the G code, and I call it, for example, .g code.txt. So the G code for this job is done. Nice folder. It's just gonna be, it's a text file mainly, and he made up of this code here, G00. That's what I did. So I did it at the first. I did at the first, and at the bottom something similar. And this is just to tell it what to do. So I'll close, and that's done for the first file. And in the next step, we're gonna do the border cutout, and we'll generate. So after finishing working with the good layer, the G code file for the drill file at the moment. So I'll select that layer. So I'll be left with the border cutout and the drill layer. So, but mainly I'll be working on a border cutout. So I'll select the border cutout cable file. So there's two. I mean, if it was rectangular shape, this border cutout, I could have just come here and select my tools and say, as you say, yes, this is border cutout. So I can say generate geometry, and it will generate the path for the tools, as you can see from here. So generate a new file. I can do the same thing and continue working on this one. But it's not the case. I've got a funny shape a bit. So what I need to come here again. And now we kind of do like isolation first. So sorry about that. So we gonna say generate geometry. So we will generate two paths around the cutout. We can also isolate that one. If we can also select that one if we don't want to see it. So we're going to have two paths, but we need to get rid of one path so we can. So we need to get rid of one path. So the way to do this, so we need to select that file. You can see if it's already been selected. So I've gone. So put it back on. Then when you do that, you come to the edit and edit geometry. With the software, you can edit geometry and add stuff to it, rectangle or anything else. But for our purposes, we need to get rid of this path here. The way to do it, you select first the path, then you draw a rectangle like this. That's a cut. We need to cut. Yeah. Then you select it again. Then you press this icon here, which is a cut path. Okay, so then we need to update the geometry, and we did cut this path in the middle here. So now we can delete them individually. So we need to go back to edit geometry, and then you can select them one by one. So that's selected, this is selected, and this is selected, and then you do press delete kind of, then you go to edit and update geometry. So that part, the internal path, gone. So we got our one path which is gonna be do the cutting. This is not enough. It will cut, the tools will cut all around it like this, but that might create a problem. What we need to do now, we need to leave a bit of space. So we cut and you stop, and then you leave space, and so on. So just to keep the board that we want, like kind of attached to the main board. So the way to do that, we select our new path. We do again edit geometry. We do it in the same as before. Then what we need to do, you need to depend how many cut you want to do. So you select this one, we did it as before. Then you draw, say for example this one here, size. Then you select it. Then you can select it again. Alright. I might to zoom in a bit So you select it, and then you press cut. Oh, it didn't work. Let me try it again. Update geometry. No, it didn't work. So edit geometry again. Well, this is a bit mad here. It's not explained properly, so we need to get rid of this. And update geometry. Then we have to do it all over again. So we need to go back to edit geometry. Then select this one. Then draw a path. Draw a cut around it like that. Then select it again. Oh, it's not selected. Sometimes it will, sometimes it doesn't. So what happened to it today? Come on. If you do update geometry, oh, it didn't work. It didn't work. So edit geometry. This one. Then cut. Other geometry. We did it now. We cut the internal. So we go back to edit geometry, and then we select only the rectangle, and we delete that one. Then update geometry, and you're gonna leave this space so the machine or the tool is gonna cut here and start again cutting from here and leave this attached to the main board. Then you're going to do the same thing. No, are we going to go left? So go right now. Oh, left. We do the same thing here. So we select the geometry. Then we select first path. Then we will draw a rectangle around it like that. Then we select it again. Then we say cut path, and then we did update geometry, and then geometry again, select that one, and we cut it. Then we did update geometry, so we got another space here. Now we're gonna need to go to the top or bottom. I'll do our. Okay, so we move into the bottom. So we do the same thing. Edit geometry. We select our path. We draw a rectangle around it, and then we select it again, and then we cut the path, and then it is other geometry, and then it's a repetitive task. It's a bit boring, but that's an easy way to go around it. It took me a bit of time to find it by test and error, because even the manual wasn't clear about it. So select that and delete it. Then update geometry. Okay, that resolves the issue. So we go up, I think. We should go up, not up where you. Now, the geometry, so it is important to do it in this way. So, edit geometry, select, this is selection tool. So, select the first path, then draw rectangle first, then press the select tools, select the rectangle, then press the cut path icon, then update geometry. Okay, so when you have this good news, then you come back here, edit geometry, select only the square or the rectangle inside, and this time you press delete and update geometry, and you have your space here. So it's important to do it the way I showed you. Trust me about that, because it took me a bit of time to figure it out. As I said before, the manual wasn't clear. So to get the whole picture, press 1, So that's what it is. Now, because now we have our path, tool path, what they call it, now we need to do the same thing as before, start working from here. So the CNC, we call it create CNC job. So we need to create CNC job because we are cutting. So we say 1.6, I think the thickness of the board, so you're going to say, what, 2 mil, and we want it to be the tools driving at millimeters, so it's not cut in, and we want it to cut past 200 again. No, so okay, so generate the G code. Sorry, the path. That's the path. That's the tools how it's gonna cut. So comes here, go to. You will see the position. They go to number 2, go like that. Then comes here, then and so on. So now we need to generate the G code for this. So as before, put G00 Z10, then G00 X0 Y0, and the same thing, but I need to change it up here. So I'll say when you finish, move the tools to on the y-axis to 250. Then I say export the G code, which create a G code. What I'll call it, or the get out G code, something like G code. .txt, and this is the second file. And in the next step, we'll show you how to do generate the drill G code from the drill file. Okay, after generating the G code for the border cutout, I don't need to see this now. Select it. Now I'm going to be working on the drill file. If you select the drill file, here it shows the different drill size, and this number is the number of the drill size. So what I do in this case, I will select one drill size to drill all this thing up to 9. So I should select the biggest one. So I select the 1 mil to drill all this hole here, and I do the rest separately. So I'll say this one plus that one plus this one. I'm going to use the drill size of 1 mil to drill all this hole. So here I will obtain the machine, the CNC job. I will take the drill to what we'll say like 2.5 mil. And when it's not drilling, it travels at 8 millimeters above the PCB, and it will travel at the speed of 100 when it's going down to drilling. And this is the speed of the spindle, 20,000 rotation per minute. So I'll ask it to generate, and you see all the hole concerned by this drill of 1 millimeters. It will show here that number. It tell you which number is going to do first, that number, whole number, or you do that, then whole number 2, and so on. Okay, so this action will generate a new file, CNC drill and the /CNC. So that's the one. Now we need to generate the G code from that file. So we select that file, and then we come here as before. We're going to say G00, put Z as safe distance of safe height of 10 millimeters, then 00 fast moving X0 10 0 Y0. Again, we say put the tools at a height of safe height of 10 millimeters, and this time move back to on a Y axis to 250 millimeters, and then I say export the G code, and then I come here and we select, I call it 1 millimeter that I was creating before, so I'll call it 1 millimeter G code for this one. Okay. After I've done this, I need to go back. I can select this just to not to confuse with the other other holes. So I come here again. I come to this drill file size. And I still got this one to do, so I'm gonna for the next one. It is 1.7 millimeter drill bit. So I select that by its own. So this is too big compared to this, so I select that. I use one drill bit to drill these holes. So in the same thing, I don't have to change anything here. So generate the CNC job for this one. So we show you here which all is affected. So generate this one here, and then I need to export the G code. So do the same thing as before. So you can leave this empty if you want, and then I'll export the G code, and I'll call this 1.7. You can call it something else if you want, or just for me to know I'm gonna be using it with the CNC machine. I know which drill size I have to use. Then also okay, select. So I know this one, this hole. I've got the hole left, so I'll select this one and select this one again, and then I got only the last size left. I think I used 3 mil for this one, so I'll leave the CNC job setting as they're the same, and create generate CNC job. So I'll go back to the file again, come back here again, and now I will add this G code. It's custom to me, so you can put whatever you like. Then even you can change the name here to reflect what you want to see. It's up to you. But then I say export G code, and I'm using 3 millimeter drill to do this job, so I'll call it 3 millimeter G code. Okay, so this is finished for the drill G code file. So we started by this 3 file, and now we have all this file added, and you can save the project, so you can come back to it another time, and call it something meaningful. I'll call it, for example, PCB engrave training, something like that. I don't know what this. Save this G code. So if we go back to the folder, so we got all this G code generated, which can be used to generate or make the PCB, one side or single-sided PCB. So we use this to engrave the top layer, to trace, and this one to do the border cutout, and this 3 file to drill the holes on the PCB. So by this we be finishing with the PCB engraving using the FLatCam.